Okay, and then question 9, part D. So I've just paused it a few times because my last recording deleted, so I don't want a big long one to delete. So this one says, the table shows the number of triangles formed by each pattern for the first 2 patterns. Complete the table to show the number of triangles formed for patterns 3 to 6. Okay, so for pattern 1, there was 1 triangle. For pattern 2, there was 3 triangles. For pattern 3, there's 1, 2, 3, 4, 5 triangles. So 5, and we can see here, so from 1 to 3, we've added 2. From 3 to 5, we've added 2. So it's going to be a linear equation. So we are going to add 2 each time. So I can fill these in as 7, 9 and 11. Okay, so that there was worth 10 marks, just filling in that table. Okay, then part 2 says the area of each triangle is 4 square root 3 centimeters squared. Find, correct to the nearest centimeter squared, the combined total area covered by the first 15 patterns in the sequence. Okay, so first 15 patterns in the sequence means that n is going to be equal to 15, and we are going to have to find what s is equal to for that. Okay, so we need to find what is a and d in this situation. So we're not just looking at this table up here, but what we're looking at is finding areas. So there's 2 ways we could do this actually. You could do it out and figure out how many combined triangles there are up until the 15th, up until that 15th term or 15th pattern, and then multiply it by the amount of area. So that could be a nice way of doing it. So let's do it that way first of all. Okay, so we'll fill in A as 1 triangle, and the difference between them each time was 2. So here we'll get, so S of n, my formula is n over 2 times 2a plus n minus 1 times d. Okay, so I'm just figuring out the triangle amount, how many triangles there are first, and then I'm going to multiply it by the area of each triangle. Okay, so n is 15, and then over 2, and then we have 2 times 1 plus n is 15 minus 1 times d, so times 2. So we'll have 15 over 2 times 2 plus 14 times 2. So we can switch between square brackets and curved brackets if we want. The square brackets are just there to differentiate, like, so that we don't have a load of curved brackets and get confused between them. Okay, so you can do square brackets, or sometimes I just do much bigger curved brackets. Okay, so 15 over 2 times 2 plus 28. So we're going to be doing 15 over 2 times 30. So this is just getting how many triangles we have up until the 15th term. So we're going to have 15 squared. So we have 225 triangles. Okay, so that's all of the triangles, including the up until and including the pattern 15. Now each of those triangles has a area of 4 square root 3 centimeters squared. So we're going to multiply that by 4 square root 3, so that we get, so multiply that by 4 square root 3, and we get 1558.8 5727. Okay, so that is our area in centimeters squared. Now it says correct to the nearest centimeter squared, so we'll just write it as 1559 centimeters squared. Okay.